The size of our discernible universe is around 93 billion light-years. In spite of endless long stretches of examination into our planetary group and the universe in general, the huge scope we're managing guarantees there will constantly be something else to find. Most of the time, it's just more stars, planets, or a few meteors. With the sensitive equilibrium the universe requires, irregularities are intriguing. However, everyone was astonished when the James Webb Telescope discovered a massive ancient force beyond the universe that can be observed. This power holds more social importance than logical, rousing a whole age. We should dig further into what this antiquated power is and how it's reshaping the universe of science. The Babylonians started concentrating on space around 1000 BCE, denoting the start of mankind's interest with the universe. Over centuries, how we might interpret space has developed close by mechanical headways. Instruments like the telescope, spearheaded by cosmologists, for example Galileo Galilei, changed our capacity to notice divine peculiarities. Galileo's revelations tested winning hypotheses and prepared for future investigations. Quick forward to now, and we have instruments like the James Webb Space Telescope, which has pushed the limits of room investigation. Its new disclosure of antiquated energy at the universe's edge is noteworthy. This energy, tracing all the way back to the universe's outset, offers experiences into vast development. Past astronomy, it holds potential for upsetting environmentally friendly power. With the intention of harnessing its power for clean and sustainable energy solutions, scientists are diligently studying its properties and behavior. Not at all like conventional petroleum products, which add to environmental change, this old energy source offers a carbon-impartial or even carbon-negative other option. By taking advantage of it, we could diminish dependence on destructive energy sources, alleviate contamination, and battle environmental change. The likely uses of this energy stretch out a long ways past astronomy, offering a practical future. Tackling this old energy source hoists our objectives of progressing to a low-carbon energy framework. State-run administrations, associations, and people overall perceive the desperation of fighting environmental change. This energy source presents a critical chance to speed up this change while guaranteeing an economical future for a long time into the future. Past its natural effect, as an old energy source enduring for billions of years, it offers the potential for long-haul energy age. Dissimilar to limited petroleum product saves, which are exhausting after some time, on the off chance that successfully bridled, this energy source could give a basically boundless and strong stockpile of clean energy. Be that as it may, to completely use its perfect and economical potential, broad innovative work endeavors are required. In order to design and improve technologies that are capable of capturing and making use of this energy, scientists must comprehend its characteristics, behaviors, and mechanisms for converting energy. Endeavors are now in progress to investigate different procedures for energy extraction, transformation, and capacity that can make this antiquated energy source suitable for common-sense applications. The information gathered by the James Webb Telescope gives an important establishment to additional investigation and investigation. Additionally, the disclosure of this antiquated energy likewise modifies how we might interpret the universe. It offers a brief look into the beginning phases of infinite development, permitting researchers to notice the central cycles forming cosmic systems, stars, and other divine items. The JWST has gained critical ground in such manner by finding 6 pristine systems, testing winning speculations of cosmology. As per current models, systems in the early universe ought to be moderately little and slowly develop bigger north of billions of years. Be that as it may, the disclosure of these enormous old worlds blows some minds, bringing up issues about existing speculations. One chance is that these cosmic systems framed through quick and extreme star development processes worked with by special circumstances in the early universe. These revelations can possibly challenge and update current hypotheses of cosmology, including the generally acknowledged lambda-CDM model. This model, in view of general relativity and consolidating ideas like dull matter and dim energy, shapes the premise of how we might interpret the universe's advancement since the enormous detonation. Notwithstanding, the presence of monstrous old worlds at such an early grandiose age presents intricacies that might expect modifications to our ongoing cosmological speculations. In outline, The disclosure of this antiquated energy source and the unforeseen presence of monstrous old worlds give significant experiences into the early universe and can possibly reshape how we might interpret cosmology. Further examination and investigation are expected to completely grasp the ramifications of these disclosures and refine how we might interpret the universe. Inside the Lambda CDM model, it assumes a significant part in the development of systems, the bunching of issue, and the general design of the universe. In any case, to comprehend the ebb and flow circumstance, scientists need to dig into world examinations with a lot more significant subtlety than previously. Accordingly, researchers have taken on new methodologies, including disclosing a staggering 3D representation of almost 5,000 universes concentrated on by the James Webb Space Telescope. Scientists can study light that has traveled vast distances through space thanks to telescopes like the JWST, which act as time machines. This capacity permits us to think back in time and witness the universe as it showed up in the far-off past. The JWST, with its high-level capacities, can recognize both apparent light and infrared waves. While apparent light perception gives data about the current situation with heavenly items, its actual power lies in examining infrared waves. Infrared radiation, with longer frequencies than apparent light, can enter through thick locales of residue and gas in space without being dispersed or retained. The JWST is able to see through cosmic dust clouds thanks to this, revealing ancient galaxies and stars that give off heat energy in the form of infrared radiation. The JWST can study light emitted by the universe's most ancient objects over 13 billion years ago using its infrared capabilities, providing a snapshot of the early universe's evolution. Concentrating on the infrared information gathered by the JWST empowers researchers to find out about the structure, elements, and qualities of these antiquated divine substances, adding to how we might interpret the universe's set of experiences. It resembles taking a virtual trip through space, spreading over billions of light years, carrying us nearer to bits of insight concealed in plain sight. Certainly. Here is the continuation. The James Webb Space Telescope, JWST, has given uncommon disclosures that are reshaping how we might interpret the universe. From old dark openings to the introduction of systems, the telescope has revealed peculiarities that challenge laid-out hypotheses. These discoveries are assisting researchers with sorting out the enormous riddle of how the universe advanced more than billions of years. The JWST's discoveries also open up new opportunities for technological innovation as we continue to investigate these frontiers. For example, the information it collects could lead to advancements in clean energy, particularly through the study of ancient cosmic forces. By opening the privileged insights of the universe's beginnings, we are likewise opening the potential for maintainable arrangements on the planet. This uncommon excursion has just barely started, and the bits of knowledge acquired from the JWST vow to alter both science and society. Through continuous examination and investigation, we edge nearer to grasping the universe's past as well as the pathways to our future. Assuming that you partook in this investigation into the secrets of the universe, remember to like, remark, and buy in. Your interest powers our journey for information, and as usual, we'll see you in the following one.